And what if I told you that Earth has been reset thousands of times? For decades, scientists have discovered unsettling patterns in our planet's geological record. Evidence suggests that Earth has experienced multiple reboots throughout its history, civilizations that flourished and disappeared, leaving behind nothing more than mysterious fragments. Entire species that evolved to reach complexity, only to be erased from the map in a matter of decades. Tonight, on Data Terra, we will explore a possibility that challenges everything we believe, we know about our past and our future. Join us on this journey through deep time, where we will discover that perhaps we are not the first advanced civilization to have inhabited this planet, and probably will not be the last. There is a number that appears again and again in humanity's oldest records: 12,000. 12,000 years appear in Sumerian texts, in Hindu traditions, and in legends of civilizations that should never have had contact with each other. The ancients spoke of cycles, of eras that ended and began, of worlds that were destroyed and renewed. For centuries, academics dismissed these narratives as primitive mythology. But what if they were not myths, but memories? Modern science has begun to reveal something extraordinary. When geologists analyze the deepest layers of ice in Greenland and Antarctica, they find evidence of dramatic climate changes that occur in surprisingly regular cycles. Approximately every 12,500 years, our planet experiences transformations that fundamentally alter life conditions on the surface. These are not gradual changes that take millennia to unfold. They are rapid transformations, almost instantaneous in geological terms, that can alter the global climate in a matter of decades. Imagine waking up one day and discovering that global temperatures have dropped 10 degrees in one decade, that rainfall patterns have completely changed, and that entire regions that were once fertile have become frozen deserts. The ice core record tells us a fascinating and terrifying story. During the last 200,000 years, our planet has experienced at least 16 of these rapid transformation events. Each one marks the end of a stable period and the beginning of something completely different. It is as if Earth has an internal reset mechanism that is regularly activated, erasing the existing conditions and creating a blank canvas for life to begin anew. But this is where the story becomes truly intriguing. If these reboots have been occurring for hundreds of thousands of years, what does this imply for the development of intelligent life? Scientists have calculated that a species needs approximately 10,000 years to develop an advanced technological civilization, starting from a hunter-gatherer state. However, the stable periods between reboots typically last between 8,000 and 15,000 years. This means that any civilization that emerged during one of these stable periods would have barely enough time to reach an advanced level before the next reboot arrived. It is a pattern that repeats itself again and again: ascent, flourishing, and sudden disappearance. Consider for a moment the implications of this. During the last 200,000 years, there have been at least 16 windows of opportunity for advanced civilizations to develop on Earth. If even half of these windows resulted in the development of complex societies, we would be talking about 8 different civilizations that could have reached levels of sophistication similar to or superior to ours. Where are their traces? Why do we not find evidence of these lost civilizations? The answer may lie in the very nature of these reboots. The events that cause these global transformations not only change the climate, but can also dramatically alter the geology of the Earth's surface. Geologists have identified several mechanisms that could function as agents of planetary reboot. Massive volcanic eruptions, such as the one that created the Deccan Traps in India, can release enough gases and ash to alter the global climate for decades. Asteroid impacts can throw so much material into the atmosphere that they block sunlight for years. Changes in ocean currents can redistribute the planet's heat in ways that completely transform climate patterns. But there is another mechanism that scientists have begun to seriously consider in recent decades: changes in solar activity. Our Sun is not a perfectly stable star. It experiences cycles of activity that can last decades, centuries, or even millennia. During periods of low solar activity, known as prolonged solar minimums, Earth receives significantly less energy, which can trigger ice ages. What is particularly unsettling is that these solar cycles seem to synchronize with the reboot patterns we observe in the terrestrial geological record. It is as if the Sun and the Earth are participating in a cosmic dance, with the Sun providing the rhythm and the Earth responding with dramatic transformations. Climate researchers have discovered that during the last 1,000 years, we have experienced several mini-reboots. The medieval warm period, which lasted from the 9th century to the 11th century, was followed by the Little Ice Age, which extended from the 14th century to the 19th century. During the Little Ice Age, global temperatures dropped so low that rivers froze in places where it had never happened before. Harvests failed systematically, and entire civilizations had to adapt or perish. If these were only mini-reboots, what could we expect from a complete reboot? Evidence suggests that a total planetary reboot could involve temperature changes of 20 degrees Celsius or more, alterations in sea levels of hundreds of meters, and complete reorganizations of global precipitation patterns. Under such conditions, even the most advanced civilizations would struggle to survive. Coastal cities would be submerged or abandoned. Agricultural regions would become uninhabitable. Trade and communication systems would collapse. In a matter of centuries, the monuments and structures of an advanced civilization could be buried under ice, ocean sediments, or eroded by extreme weather conditions. This would explain why we do not find obvious evidence of previous civilizations, not because they did not exist, but because the very processes that eliminated them also erased most of their traces. Only the most massive and durable structures would have any chance of surviving multiple reboot cycles. And this is where things become truly fascinating, because when we begin to search for structures that could have survived previous reboots, we start to find them. Ancient megaliths that defy our understanding of the technological capabilities of the civilizations that supposedly built them. Archaeological sites that appear to be much older than should be possible. Artifacts that do not fit into our established chronology of human development. It is possible that these are not anomalies or errors in the archaeological record. They could be exactly what we would expect to find if previous civilizations had existed and had been subjected to planetary reboots. The fragmentary survivors of lost worlds, preserved by sheer chance or by their extraordinarily robust construction. The next time you gaze at the stars on a clear night, consider this possibility, that the history of intelligence on Earth could be much older and more complex than we have ever imagined, that we are perhaps only the latest chapter in a long history of ascent, flourishing, and renewal, and that somewhere, buried under kilometers of ice or ocean sediments, could lie the remains of civilizations that once looked at these same stars and wondered about their place in the cosmos. 12,900 years ago, something extraordinary and terrifying occurred on our planet. In the span of barely a few decades, global temperatures plummeted, plunging Earth into what scientists have called the Younger Dryas, a sudden ice age that lasted more than 1,000 years. But what is truly unsettling about this event was not only its intensity, but its speed. Imagine a world where, in the lifespan of a single generation, entire regions that had been temperate and habitable transformed into frozen, uninhabitable tundras. Ice cores extracted from Greenland tell us a story that challenges everything we thought we knew about climate change. Air bubbles trapped in the ice reveal that temperatures in the North Atlantic dropped up to 15 degrees Celsius in less than a decade. To put it in perspective, this is equivalent to the average temperatures of Spain becoming similar to those of Siberia in a matter of years. But extreme cold was only the beginning. Precipitation patterns were dramatically altered. The ocean currents that had distributed heat around the planet for millennia abruptly stopped. The Gulf Stream, that warm current that keeps the European climate temperate, shifted southward, leaving much of Europe submerged in Arctic conditions. The monsoons that had nourished the civilizations of Asia weakened or disappeared completely. Geologists have found evidence of this climate collapse on all continents. In North America, vast regions that had been ice-free for thousands of years were covered again by glaciers. In Europe, temperate forests were replaced by Arctic steppe. In North Africa, what had been green savanna transformed into the Sahara Desert that we know today. What caused this sudden climate reboot? For decades, scientists debated multiple theories. Some proposed that massive volcanic eruptions had blocked sunlight. Others suggested that changes in the Earth's orbit had altered the distribution of solar energy. But in recent decades, a different theory has gained acceptance: the Younger Dryas impact hypothesis. According to this theory, a comet or asteroid fragment impacted or exploded in the atmosphere over North America exactly 12,900 years ago. The evidence for this hypothesis is compelling. Scientists have found a layer of sediments dated precisely to the beginning of the Younger Dryas that contains anomalous levels of iridium, an element rare on the terrestrial surface but common in asteroids and comets. Furthermore, this layer contains glass microspheres formed by extreme heat, microscopic diamonds created by immense pressures, and charcoal in quantities that suggest continental forest fires. All of this points toward a catastrophic impact event that would not only have caused massive local destruction, but also would have thrown enough material into the atmosphere to alter the global climate. But this is where the story becomes truly intriguing from the perspective of lost civilizations. The Younger Dryas began precisely at the end of the Pleistocene, an epoch that archaeologists have identified as a period of accelerated cultural development for humanity. During the millennia prior to the Younger Dryas, humans had developed sophisticated tools, complex art, and possibly the earliest forms of agriculture. The Clovis culture in North America, known for its finely carved spearheads, disappeared abruptly at the beginning of the Younger Dryas. The Pleistocene megafauna, including mammoths, mastodons, saber-toothed tigers, and dozens of other species that had coexisted with humans for millennia, became extinct suddenly. In Europe, the artistic traditions of the Upper Paleolithic that had produced the cave paintings of Lascaux and Altamira came to an end. Traditional archaeologists explain these disappearances as the natural result of climate change and human hunting pressure. But what if there was a more radical explanation? What if the Younger Dryas not only marked the end of primitive species and cultures, but also the end of civilizations that had reached levels of sophistication that we are barely beginning to imagine? Consider the most enigmatic archaeological evidence from this period. Göbekli Tepe in Turkey, which was constructed precisely at the end of the Younger Dryas, required a level of social organization and technical knowledge that supposedly did not exist at that time. The megalithic structures of Karahantepe and Nevala Chori, also in Turkey, show architectural similarities that suggest a continuous construction tradition extending through the Younger Dryas. It is possible that these sites do not represent the beginnings of civilization, but rather the remnants of civilizations that survived the Younger Dryas reboot. The builders of Göbekli Tepe demonstrated knowledge of astronomy, geometry, and engineering that should not have existed according to our established chronology of human development. They carved limestone pillars weighing up to 16 tons, transported them considerable distances, and organized them into complex patterns that seem to map constellations. Radiocarbon dating indicates that Göbekli Tepe was deliberately buried around the year 8000 before the Common Era, as if its builders had wanted to preserve it for posterity before abandoning the site. This pattern of deliberate construction, followed by intentional burial, appears in several megalithic sites around the world, suggesting a coordinated response to some type of threat or environmental change. But the most intriguing evidence of pre-Younger Dryas civilizations might lie beneath the sea. During the last glacial maximum that ended just before the Younger Dryas, sea levels were approximately 120 meters lower than they are today. This means that vast areas of what are now continental shelves were exposed and available for human habitation. These coastal regions would have been the most favorable for the development of advanced civilizations. They had access to abundant marine resources, rivers for transport and agriculture, and moderate climates due to their proximity to the ocean. If sophisticated civilizations had developed in these regions during the late Pleistocene, they would have been flooded when sea levels rose at the end of the Ice Age. Marine archaeologists have begun to find intriguing evidence of human habitation in these submerged areas. Stone structures in the Mediterranean that could be the remains of human constructions, carved tools, found on continental shelves at depths that indicate a much greater antiquity than expected, and geological formations that appear too regular to be natural. The Younger Dryas event would have been particularly devastating for any coastal civilization. Not only would they have had to deal with the sudden climate collapse, but also with the flooding of their most valuable territories when the glaciers began to melt. It is a scenario that could have led to the total collapse of even the most advanced societies. Imagine a civilization that had developed sophisticated agriculture, complex cities, and extensive trade networks, all based in the coastal regions of the Pleistocene. In a matter of decades, their population centers would have been submerged, their agricultural systems would have collapsed due to extreme climate changes, and their trade networks would have fragmented due to impossible environmental conditions. The survivors of such a collapse would have had to start over, possibly in mountainous or inland regions that had been marginal during the previous period. With fragmented technical knowledge, dispersed populations, and the urgent need for basic survival, it would have taken millennia to reconstruct even a fraction of the previous sophistication. This narrative would explain many of the anomalies we find in the post-Younger Dryas archaeological record. Why does agriculture seem to have emerged simultaneously in multiple regions of the world shortly after the end of the Ice Age? Possibly because the survivors of earlier civilizations preserved some agricultural knowledge and re-implemented it when conditions allowed. Why do we find similar mythological traditions about catastrophic floods and lost worlds in cultures that supposedly had no contact with each other? Possibly because these are not myths, but cultural memories of real events experienced by earlier civilizations. Why do the earliest post-glacial architectural and urban developments seem to appear fully formed, without clear evidence of gradual development? Possibly because they represent the re-implementation of knowledge and techniques that had existed previously, but had been lost and slowly recovered. The Younger Dryas teaches us something fundamental about the fragility of civilization. Even the most robust systems can collapse when faced with sufficiently rapid and extreme environmental changes. And once a civilization collapses completely, its achievements can disappear from the historical record in surprisingly little time. As you contemplate this possibility tonight, consider that the Younger Dryas may not have been unique. Paleoclimate records suggest that similar events have occurred multiple times throughout Earth's history. each one representing a potential reboot of civilization, an opportunity for the world to begin anew, but also a lost opportunity for cultural and technological continuity. In the silence of these nocturnal hours, as the world rests around you, the ice at the poles continues to preserve the memories of these ancient reboots, waiting for scientists to read them and understand the lessons that could prepare us for the next great change that may be coming. 74,000 years ago, on what is today the island of Sumatra in Indonesia, an event occurred that nearly wiped humanity from the face of the earth. The Toba volcano erupted with a force so devastating that scientists have classified it as a super eruption, a phenomenon so rare that it occurs only once every several 100,000 years. To understand the magnitude of this catastrophe, imagine an explosion 8,000 times more powerful than the eruption of Mount St. Helens, so immense that its effects were felt across the entire planet for decades. The Toba eruption was not simply another natural disaster in Earth's history. It was an evolutionary reboot that forever altered the course of human development. Geneticists have discovered fascinating and terrifying evidence of this event in our own DNA. When they analyze the genetic diversity of the current human population, they find something extraordinary. All modern humans descend from an incredibly small group of survivors who lived approximately 70,000 years ago. This phenomenon, known as the genetic bottleneck, suggests that at some point in our recent past, the human population was reduced to just a few thousand individuals, possibly fewer than 10,000 people on the entire planet. To put it in perspective, this means that at one time, there were fewer living humans than could fit in a modern football stadium. All the diversity, all the complexity, all the richness of current humanity emerged from this small group of survivors. The temporal coincidence between the Toba eruption and this genetic bottleneck is not accidental. Volcanologists have reconstructed what would have happened when Toba exploded, and the scenario is apocalyptic. The eruption ejected approximately 2,800 cubic kilometers of material into the atmosphere, a quantity so immense that it would have covered the entire Iberian Peninsula with a layer of ash several meters thick. But the ash was only the beginning of the disaster. Volcanic gases, mainly sulfur dioxide, combined with water vapor in the atmosphere to form sulfuric acid aerosols that blocked sunlight for years. Global temperatures dropped between 3 and 5 degrees Celsius, triggering what scientists call a volcanic winter. For 6 to 10 years, the Earth was submerged in perpetual gloom with frigid temperatures that made agriculture impossible and decimated ecosystems worldwide. The effects were particularly devastating in the tropical regions where most of the human population lived at the time. Tropical forests, which had been the home of our ancestors for millions of years, withered and died. Water sources were contaminated with volcanic ash. The animals on which humans depended for food migrated or became extinct en masse. Anthropologists have calculated that before the Toba eruption, the global human population might have reached several 100,000 individuals, distributed mainly across Africa and parts of Asia. These populations had developed sophisticated cultures for their time, with specialized tools, symbolic art, and possibly early forms of complex language. But when Toba erupted, these emerging societies were devastated. Populations living in Asia, closer to the volcano, were likely almost completely eliminated. In Africa, only those communities lucky enough to be in especially favorable ecological refuges managed to survive the prolonged volcanic winter. Geneticists have identified specific evidence of this event in our chromosomes. Genetic variation in the Y chromosome, which is passed from father to son, shows signs of a dramatic reduction in the male population approximately 70,000 years ago. Similarly, Mitochondrial DNA, which is inherited through the maternal line, indicates that all current human women descend from a very small number of female ancestors who lived during this period. This genetic bottleneck had profound and lasting consequences for our species. On the one hand, it would explain why modern humans show remarkably low genetic diversity compared to other primate species. Our closest relatives, chimpanzees, which never experienced such a severe bottleneck, show much greater genetic variability, despite having smaller populations today. But the Toba event may also have accelerated certain aspects of human evolution. Small populations under extreme stress experience intense selective pressures. Only individuals with the most advantageous adaptations manage to survive and reproduce. It is possible that many of the characteristics we consider fundamentally human, such as our exceptional capacity for cooperation, technological innovation, and complex communication, were intensified during this period of extreme survival. Archaeologists have found intriguing evidence of accelerated cultural changes immediately after the Toba period. Stone tools suddenly become more sophisticated. The first clear examples of symbolic art and personal ornaments appear. Hunting techniques diversify and intensify. It is as if the survivors of the volcanic disaster emerged with enhanced capacities for adaptation and innovation. This post-Toba transformation marks the beginning of what anthropologists call modern human behavior. Within 20,000 years after the eruption, humans had developed technologies advanced enough to colonize new continents, crossing the sea to Australia, and eventually expanding into Europe and the Americas. But what was there before Toba? What types of societies and cultures were lost in that evolutionary reboot? Archaeological records from this period are fragmentary, partly due to the destruction caused by the eruption itself, but also because pre-Toba populations might have reached levels of sophistication that we are barely beginning to appreciate. Some archaeologists have proposed that pre-Toba human populations might have developed forms of social organization and technology that were completely lost during the bottleneck. The evidence is speculative but intriguing. Archaeological sites in Africa that show signs of early urban planning, tools that seem too advanced for the assigned dates, and rock art that suggests complex, symbolic systems. The Toba eruption would have functioned as an extremely selective, evolutionary, and cultural filter. Only the most basic survival techniques and the most essential knowledge would have been preserved by the small survivor populations. More elaborate cultural traditions, specialized knowledge, and technologies that required large populations to sustain would have been lost forever. This pattern of knowledge loss during catastrophic events is something we can observe even in historical times. When civilizations collapse due to natural disasters, wars, or environmental changes, they often lose not only their populations, but also their most advanced intellectual and technical achievements. The Library of Alexandria, Roman engineering knowledge, the agricultural techniques of pre-Columbian civilizations, all examples of how accumulated knowledge can quickly disappear when the societies that sustain it fragment. Toba teaches us that this type of reboot can occur on a much more fundamental scale, not just the collapse of a particular civilization, but the reboot of the entire human species. Geneticists have calculated that it took approximately 40,000 years for the human population to fully recover from the Toba bottleneck and reach significant numbers again. During those 40 millennia of slow recovery, how many innovations were lost and had to be rediscovered? How many cultural traditions disappeared forever? How many alternative paths of human development were permanently closed by this evolutionary reboot? The Toba story also reminds us that similar events could happen again. Volcanologists have identified several current volcanic systems that have the potential to produce super eruptions. Yellowstone in the United States, the Phlegrean Fields in Italy, Taupo in New Zealand, all are candidates for future eruptions that could rival Toba in scale and devastation. But unlike our ancestors, 74,000 years ago, modern humanity faces an additional dilemma. We are a globalized species with a population of 8 billion people, most concentrated in dense urban areas that depend on complex and interconnected supply systems. A modern super-eruption could not only cause direct death and destruction, but also completely collapse the technological and economic systems on which we depend. At the same time, we have capabilities that our ancestors did not have. We can predict volcanic eruptions with some accuracy, store knowledge in forms that could survive global catastrophes, and possibly develop technologies to mitigate the effects of massive volcanic events. The unsettling question is whether these modern capabilities would be enough to avoid another Toba-type bottleneck, or if they would merely postpone the inevitable. Climate models suggest that a modern supereruption could have even more devastating effects than Toba due to the higher concentrations of carbon dioxide in the current atmosphere, which could amplify the effects of volcanic cooling. As you rest in the silence of this night, consider that every breath you take, every beat of your heart, carries within it the genetic memory of those few thousand survivors who managed to persevere through the longest and darkest volcanic winter our species has ever known. We are all descendants of those who refused to surrender when the world became cold and dark, when food sources disappeared, and when survival itself seemed impossible. In their genes, we carry not only the evidence of that ancient catastrophe, but also the capacity for resilience that allowed them to overcome it and give rise to all the diversity and complexity of modern humanity. In the arid hills of southeastern Turkey, 15 kilometers from the city of Şanlıurfa, stands one of the most perplexing archaeological mysteries of our time. Göbekli Tepe, which means Potbelly Hill in Turkish, is a site that defies everything we thought we knew about the development of human civilization. When the German archaeologist Klaus Schmidt began serious excavations at this location in 1996, he did not imagine that he was about to rewrite human history. What Schmidt and his team discovered under centuries of sediment was impossible, according to all established theories of human cultural evolution. Massive circles of limestone pillars, some up to 5.5 meters high and weighing 16 tons, organized in complex patterns and decorated with intricate reliefs of animals, abstract symbols, and stylized human figures. But what made this discovery truly revolutionary was not only the sophistication of the construction, but its antiquity. Radiocarbon dating revealed something that seemed impossible. Göbekli Tepe was built approximately 11,500 years ago at the end of the Younger Dryas, when, according to our history books, humanity was barely beginning to domesticate plants and animals. This site not only predates Stonehenge by 6,000 years, but is older than agriculture, pottery, metallurgy, and writing. It was built by people who were supposedly nomadic hunter-gatherers, living in small dispersed groups. How is it possible that hunter-gatherers could have undertaken a construction project that required sophisticated planning, advanced engineering knowledge, and the coordination of hundreds, possibly thousands, of workers over generations? The conventional answer is that it is not possible, and yet, there is Göbekli Tepe, challenging our most fundamental assumptions about the human past. To truly understand the anomaly that Göbekli Tepe represents, we must consider what its construction implies. The limestone pillars were not carved at the site itself. They were extracted from quarries located several hundred meters away, precisely carved using tools that left marks consistent with highly developed stoneworking techniques, and then transported and erected with a precision that suggests advanced engineering knowledge. The reliefs engraved on the pillars show a level of craftsmanship that rivals the best sculptures of later civilizations. Lions, wild boars, bulls, snakes, scorpions, vultures, and dozens of other species are represented with a realism and attention to detail that suggests not only exceptional artistic skill, but also a deep knowledge of animal anatomy and possibly religious or astronomical symbolism. But perhaps the most intriguing are the abstract symbols that appear repeatedly on the pillars: circles, wavy lines, complex geometric figures, and what appear to be pictograms or proto-writing. Some researchers have suggested that these symbols could represent constellations, astronomical calendars, or even early forms of writing that precede Mesopotamian writing systems by thousands of years. The overall design of Göbekli Tepe also suggests sophisticated astronomical knowledge. The circles of pillars appear to be oriented toward specific points on the horizon, where certain stars or constellations would have appeared at particular times of the year, 11,500 years ago. It is as if the site was designed as a massive astronomical observatory, a place where our ancestors may have tracked the movements of celestial bodies with a precision that required generations of careful observation. But Göbekli Tepe presents another, equally disconcerting mystery. Around the year 8000, before the Common Era, approximately 3,500 years after its construction, the site was deliberately buried, not gradually abandoned, not destroyed by enemies or natural disasters, but carefully and intentionally covered with tons of sediment and stones. Someone made the conscious decision to preserve Göbekli Tepe by burying it, as if they wanted to protect it for future generations. This pattern of intentional burial appears in several other megalithic sites in the region and period: Nevaluchori, Karahan Tepe, Hamzan Tepe. All show evidence of having been deliberately buried after periods of use extending across millennia. It is as if the builders of these monuments followed a specific tradition of preservation that is completely foreign to us. What kind of society could have created Göbekli Tepe? Conventional archaeological theories struggle to explain how hunter-gatherers could have achieved such a level of organization and technical sophistication. Explanations have been proposed, involving complex confederations of nomadic tribes, religious cults that unified dispersed groups, or emerging elites that coordinated massive construction projects. But there is another possibility that archaeologists have been reluctant to seriously consider. What if Göbekli Tepe does not represent the beginning of civilization, but the remnants of a civilization that survived a previous reboot? What if its builders were not primitive hunter-gatherers, suddenly developing advanced capabilities, but survivors of more complex societies that had been devastated by catastrophic events like the Younger Dryas? This perspective would completely alter our interpretation of the site. Instead of viewing Göbekli Tepe as an anomalous and inexplicable development, we would see it as exactly what we would expect to find after a civilizational reboot: a monumental project undertaken by groups who preserved fragments of advanced knowledge from earlier times. The survivors of pre-Younger Dryas civilizations would have had powerful motives for creating a site like Göbekli Tepe. First, it would have served as a center of congregation for dispersed populations, a place where the surviving fragments of the former society could gather, exchange knowledge, and coordinate reconstruction efforts. Second, it would have functioned as a repository of important knowledge. The reliefs and symbols of Göbekli Tepe would not be merely decorative, but mnemonic, ways of preserving crucial information about astronomy, agriculture, navigation, and other technical knowledge, in a form that could survive, even if oral traditions fragmented. Third, the site would have had a ritual and psychological purpose. affirming cultural continuity and providing hope to populations traumatized by catastrophes. The construction itself would have been an act of defiance against the forces that had destroyed the former world, a declaration that humanity would persist and rebuild. This interpretation would explain many of the seemingly anomalous characteristics of Göbekli Tepe. Its sudden technical sophistication would make sense if it represented the application of preserved knowledge rather than the independent development of new techniques. Its complex astronomical orientation would be natural if it were built by people who already had traditions of celestial observation developed over previous millennia. The deliberate burial of the site would also fit into this narrative. Once populations had stabilized and begun to develop new centers of civilization, Göbekli Tepe would have fulfilled its purpose as a post-catastrophe refuge. Its builders would have buried it not to abandon it, but to preserve it as a monument to human survival and resilience. Recent archaeological surveys have revealed that Göbekli Tepe is only the tip of the iceberg. Using remote sensing technologies, researchers have identified hundreds of similar sites throughout the region, most of them still unexcavated. It is possible that the entire region of southeastern Anatolia is filled with megalithic monuments from this period, suggesting a much more extensive construction tradition than we ever imagined. Some of these sites show evidence of having been connected by ancient roads and communication systems. Karahan Tepe, located 60 kilometers southeast of Göbekli Tepe, shows remarkably similar architectural and decorative styles, as if it had been built by the same cultural tradition. Bonkuklu Tala, recently discovered, contains structures that might be even older than Göbekli Tepe. This network of megalithic sites suggests something more than isolated construction projects undertaken by dispersed groups. It indicates a coherent civilization with shared architectural traditions, developed communication systems, and the capacity to coordinate projects extending across vast geographical regions over millennia. Analysis of pollen and sediments from the sites reveals something else intriguing: evidence of early agriculture and sophisticated environmental management that predates the development of agriculture in other regions by millennia. It is as if the builders of these monuments had not only preserved architectural and astronomical knowledge, but also advanced agricultural techniques that allowed them to sustain the necessary populations for massive construction projects. As you contemplate the mystery of Göbekli Tepe in the silence of this night, consider that this site could represent something deeper than an archaeological anomaly. It could be direct evidence that human history is much older, more complex, and more discontinuous than we have assumed. That the capacities to create lasting monuments, preserve complex knowledge, and organize sophisticated societies might have existed long before our conventional chronologies suggest. In the carved stones of Göbekli Tepe, in its mysterious symbols and its precise astronomical orientations, we might be seeing the last echoes of lost worlds, the final traces of civilizations that once flourished and were erased by forces we are barely beginning to understand. And in its careful and deliberate burial, we might be witnessing an act of hope, the intentional preservation of knowledge and achievements so that future generations could find them, study them, and perhaps learn from them when they were ready to grasp their true meaning. In the silence of space, beyond the protective atmosphere that envelops our world, millions of rocky and metallic objects travel, following silent orbits around the Sunday. Most are small, the size of pebbles or rocks, and harmlessly disintegrate when they come into contact with our atmosphere, creating the shooting stars we admire on clear nights. But some are different. Some are large enough to survive the journey through the atmosphere and strike the surface of our planet with a force that can alter the course of history. During the last 4 billion years, Earth has been repeatedly bombarded by these cosmic visitors. The impact craters that dot our planet are the scars of these encounters, each one marking a moment when forces from outer space dramatically intervened in the evolution of terrestrial life. Some of these impacts were powerful enough to function as complete planetary reboots, erasing dominant life forms and creating opportunities for new species to evolve and flourish. The most famous example of an asteroid impact reboot occurred 66 million years ago at the end of the Cretaceous period. An asteroid approximately 10 kilometers in diameter crashed into what is today the Yucatan Peninsula in Mexico, creating the Chicxulub crater. The energy released by this impact was equivalent to several billion atomic bombs detonating simultaneously, but the initial explosion was only the beginning of the disaster. The impact threw trillions of tons of pulverized rock, superheated water vapor, and toxic gases into the atmosphere. Incandescent rock fragments were launched over intercontinental distances, starting massive forest fires across the planet. A cloud of dust and soot enveloped the Earth, blocking sunlight for months and causing a collapse of photosynthesis that extended from terrestrial plants to oceanic phytoplankton. The creatures that had dominated terrestrial ecosystems for 160 million years, the dinosaurs, became almost completely extinct. Along with them, many species of plants, mammals, birds, marine reptiles, and microscopic life forms that had formed complex ecological networks disappeared. It was a reboot so complete that paleontologists use it as a marker to divide two entire geological eras, the Mesozoic and the Cenozoic. But impact reboots did not end with the dinosaurs. The geological record is full of evidence of later impacts that could have dramatically affected the development of intelligent life on our planet. 35 million years ago, another massive impact created the Popigai crater in Siberia. 15 million years ago, the Ries impact in Germany significantly altered European ecosystems. Barely 2 million years ago, multiple impacts in the southern hemisphere might have influenced climate patterns that affected early human evolution. What is particularly unsettling is that these massive impacts are not events of the distant past that we can ignore. They occur with a regularity that suggests they are a normal feature of planetary existence. Astronomers have calculated that impacts of the caliber of the one that eliminated the dinosaurs occur approximately once every 50 to 100 million years. Impacts large enough to cause significant civilizational disruptions could occur every several 100,000 years. During the last centuries, humanity has begun to realize that we live in a cosmic firing range. The Tunguska event in 1908, when an object barely 50 meters in diameter exploded over Siberia with the force of 500 atomic bombs, gave us a glimpse of what larger objects could do. The Chelyabinsk meteor in 2013, which injured more than 1,500 people when it exploded over Russia, reminded us that these events continue to occur without warning. But what if asteroid impacts had functioned as reboot agents, specifically for advanced human civilizations? What if events like Tunguska, but of greater magnitude, had occurred at critical moments in human history, erasing entire societies before they could leave lasting records of their achievements? Scientists studying impacts have begun to seriously consider this possibility. An asteroid of only 200 meters in diameter, much smaller than the one that eliminated the dinosaurs, could devastate an area the size of a European country. An object 1 kilometer in diameter could cause global climate effects lasting decades, and objects of this size impact the Earth much more frequently than the truly massive impacts. Statistical analysis suggests that during the last 200,000 years of human existence, our planet should have experienced at least several impacts large enough to cause significant civilizational disruptions. Some of these could have occurred in oceans or in uninhabited regions, but others could have struck human population centers directly. The effects of an asteroid impact on an advanced civilization would be devastating in ways that go beyond immediate physical destruction. Communication and transportation systems would collapse, fragmenting the commercial and cultural networks that sustain complex societies. Food supply chains would be interrupted, causing massive famines. Technical knowledge stored in urban centers would be lost when those cities were abandoned. But perhaps most importantly, the infrastructure necessary to maintain and transmit advanced knowledge would disappear. The libraries, schools, specialized workshops, and communication networks that allow societies to preserve and develop complex knowledge for generations would be destroyed or abandoned. Survivors would be forced to concentrate on immediate survival, and intellectual and technical traditions would fragment or disappear completely. This scenario would explain an unsettling pattern that some researchers have noted in the human archaeological record, evidence of sophisticated technical and cultural developments that appear suddenly, flourish for relatively short periods, and then disappear seemingly for no reason. Could these represent civilizations that were interrupted by impact events before they could establish lasting traditions? The Earth's oceans could contain evidence of such events. Ocean impacts are much more likely than terrestrial impacts, simply because the oceans cover 71% of the planetary surface. A moderate-sized asteroid impacting the ocean would create tsunamis that could devastate all coastal civilizations in an area of thousands of kilometers. For most of human history, the most advanced civilizations have developed in coastal regions. Rivers and coasts provide transportation, commerce, food resources, and moderate climates that favor urban development. A single, well-located ocean impact could eliminate multiple civilizational centers simultaneously, causing a coordinated collapse that would be much more devastating than localized disasters. Marine geologists have begun to find intriguing evidence of relatively recent ocean impacts. Underwater craters dating to periods that correspond with known civilizational collapses, tsunami deposits that suggest waves much larger than those that could be caused by earthquakes or volcanic eruptions, and layers of sediment containing materials that could only come from high-energy impacts. The chronology of these possible impact events is particularly intriguing. Several coincide with the transition periods we have discussed in previous chapters: the end of the Younger Dryas, the civilizational collapses during the Middle Holocene, and other moments of rapid change in human history. It is possible that some of the reboots we have attributed to climate change, volcanic eruptions, or internal collapses were actually caused by asteroid impacts that we have not yet identified. The secondary effects of an impact climate change, increased volcanic activity, disruptions in ocean currents, could mask the original cause of the disaster. Modern astronomers have begun to systematically catalogue the objects that could represent future threats to human civilization. Potentially hazardous asteroids, objects more than 140 meters in diameter, whose orbits bring them close to Earth, total more than 2,000 known objects. But the surveys are far from complete, and new potentially threatening objects are discovered regularly. Modern technology gives us capabilities that earlier civilizations did not have to detect and possibly deflect dangerous asteroids. Missions like NASA's DART have demonstrated that we can alter the orbits of asteroids using kinetic impacts. More advanced concepts involve the use of gravitational tractors, solar sails, or even nuclear weapons to deflect threatening objects. But we also face vulnerabilities that earlier civilizations did not have. Our dependence on complex and interconnected technological systems means that even relatively small impacts could cause cascading collapses that would be disproportionately devastating. An asteroid that destroyed a major communications hub or caused an electromagnetic pulse could disrupt global systems in a way that would affect billions of people. More concerningly, our globalized civilization means that a single impact event could simultaneously affect multiple regions of the world. Trade and supply networks that allow us to sustain large urban populations also create single points of failure that could dramatically amplify the effects of a cosmic disaster. Computational models of asteroid impacts on modern civilization suggest scenarios that are simultaneously familiar and terrifying. Infrastructure collapses that take decades to repair, agricultural disruptions that cause global famines, and fragmentation of knowledge networks resulting in permanent losses of technical capabilities. In other words, exactly the type of civilizational reboot we might expect based on the patterns we have observed in the past. But there is a crucial difference between past impact reboots and potential future reboots. For the first time in our planet's history, a species is aware of the threat and has at least the theoretical capacity to do something about it. The question is whether we will have the will, the resources, and the international cooperation necessary to implement effective planetary defenses before the next major impact arrives. In the silence of these nocturnal hours, as the world sleeps around you, thousands of rocky objects continue their silent journey through the inner solar system. Most will harmlessly pass by, their trajectories precisely calculated by computers that constantly monitor the skies. But others remain undetected, waiting in the cosmic darkness, carrying the potential for another chapter in the long history of reboots that have shaped the destiny of life on Earth. In the year 360 before the Common Era, the Greek philosopher Plato wrote about an extraordinary civilization that had existed 9,000 years before his time. He described it as an advanced society that had flourished on an island beyond the Pillars of Hercules, with magnificent cities, sophisticated technology, and a naval power that rivaled the greatest known empires. According to Plato, this civilization, which he called Atlantis, had suddenly disappeared in a single day and night of misfortune, sinking beneath the ocean waves. For more than 2 millennia, scholars have debated whether Atlantis was a philosophical allegory invented by Plato or a distorted memory of real events. But in recent decades, marine archaeologists have begun to discover something that could validate at least the central premise of Plato's story, that advanced civilizations existed in regions that are now underwater, and that dramatic changes in sea level have functioned as mechanisms of civilizational reboot throughout human history. To understand how this is possible, we must consider the massive changes that have occurred in sea levels during the period of human existence. 20,000 years ago, during the last glacial maximum, enormous quantities of water were trapped in continental ice sheets that covered much of North America, Northern Europe, and other regions. As a result, global sea levels were approximately 120 meters lower than they are today. This means that vast areas that are now submerged were then exposed and available for human habitation. The continental shelves that extend from modern coasts toward the deep oceans were dry land with rivers, lakes, forests, and all the resources necessary to sustain complex civilizations. In fact, these regions would have been particularly attractive for human development due to their access to both terrestrial and marine resources. When the ice sheets began to melt at the end of the Ice Age, the resulting rise in sea level was not gradual. Studies of ice cores and marine sediments revealed that it occurred in rapid pulses, with periods of accelerated rise that could have raised sea levels several meters in a matter of decades. During these events, known as meltwater pulses, entire regions that had been habitable for millennia became permanently submerged. The first major pulse called meltwater pulse 1A, occurred approximately 14,700 years ago and raised sea levels about 20 meters. The second major pulse, approximately 11,600 years ago, added another 10 to 15 meters. But these were only the most dramatic events. There were multiple minor episodes of rapid sea level rise that continued until approximately 6,000 years ago. For any civilization that had flourished in the coastal regions during the glacial period, these flooding pulses would have been catastrophic. Imagine entire cities, agricultural systems, developed over generations, and complex trade networks being permanently submerged in the course of a few decades. The survivors would have been forced to migrate to higher ground, abandoning not only their homes, but also the cultural and technological infrastructure that had sustained their civilization. Marine archaeologists have begun to find evidence that this is exactly what occurred in the Mediterranean. Researchers have identified stone structures on the seabed that appear too regular and organized to be natural formations off the coast of Malta, at depths that correspond to sea levels 8,000 years ago. What appear to be ruins of megalithic temples, similar to those found on the island's surface, have been discovered. In the Black Sea, oceanographers Robert Ballard and Frederick Hibert have found evidence of a catastrophic flooding event that occurred approximately 7,600 years ago. According to their theory, the Black Sea was originally a much smaller freshwater lake, surrounded by fertile lands that would have been ideal for the development of early agriculture. When the rise in global sea level caused the Mediterranean to overflow through the Bosphorus, the salt water rushed into the lake with a force equivalent to 200 times Niagara Falls. This event would have submerged approximately 155,000 square kilometers of habitable land in a matter of years, an area equivalent to the surface of Greece. Any civilization that had existed in these lands would have been forced to evacuate precipitously, taking only what they could carry and losing their urban centers, monuments, and cultural records forever. Seismic surveys of the Black Sea floor have revealed evidence of submerged human settlements, including rectangular structures that could be the remains of buildings, and erosion patterns that suggest ancient riverbeds and coastlines. But most intriguing are the sediment deposits that show signs of having been removed and organized in ways that suggest human activity, possible evidence of agriculture or construction that was preserved beneath the waters. In India, marine archaeologists have made even more spectacular discoveries. Off the coast of Gujarat, in the Gulf of Khambhat, they have found submerged ruins that appear to include massive stone structures, possible fortification walls, and artifacts suggesting a sophisticated civilization that could have existed more than 9,000 years ago. Seismic studies have revealed what appear to be the outlines of an ancient city with regular streets and buildings, organized according to a coherent urban plan. Further south, off the coast of Tamil Nadu, submerged structures have been discovered that could be the remains of Pumpuhar, an ancient city mentioned in classic Tamil texts that was supposedly submerged by the sea. The texts describe a magnificent city with palaces, temples, and gardens that disappeared under the waves during a catastrophic flood. For decades, scholars assumed these were mythical legends, but underwater archaeological findings suggest they might be based on real events. In Japan, the submerged Yonaguni structures have generated decades of archaeological debate. These rock formations, which include what appear to be carved steps, leveled platforms, and right angles too regular to be natural, are located at depths that indicate they were formed when sea level was significantly lower. Although some geologists argue that the structures are natural formations altered by erosion, other researchers maintain that they show clear evidence of human modification. What is particularly intriguing about these underwater finds is that many of them show levels of sophistication that seem inconsistent with our understanding of human technological development during the periods in question. The Kambat structures, for example, suggest engineering and urban planning capabilities that were supposedly not developed until thousands of years later in the conventional archaeological chronology. This leads us to an unsettling possibility that our understanding of the chronology of human development might be fundamentally biased because the evidence of the earliest and most advanced civilizations is buried under hundreds of meters of ocean water. The regions where these civilizations developed the most fertile and favorable coastal lands of the glacial world are exactly the areas that are now most deeply submerged. Traditional archaeological methods, which rely on terrestrial excavations, could never have detected these lost civilizations. Only the development of underwater exploration technologies in recent decades has made it possible for us to begin to glimpse what might be waiting on the seabed. And given that we have explored less than 5% of the world's oceans with the detail necessary to identify archaeological remains, it is likely that these findings represent only a small fraction of what actually exists. Sea level changes not only functioned as mechanisms of destruction for coastal civilizations, they also created geographical barriers that could have fragmented populations and cultures. When sea levels rose, many islands that were previously connected by land bridges were permanently separated. Populations that had shared cultures and technologies suddenly found themselves isolated, forced to develop independently without the benefits of cultural and commercial exchange. This pattern of fragmentation and isolation could explain some of the discontinuities we observe in human cultural development. Why do similar technologies seem to have been invented independently in multiple regions of the world? Possibly because they were originally developed by a unified civilization that was subsequently fragmented by geographical changes. Why do we find similar mythical traditions about catastrophic floods and lost lands in cultures on all continents? Possibly because these traditions preserve real memories of events that affected global civilizations during the sea level rise pulses of the early Holocene. Plato's story of Atlantis might be more accurate than we have assumed, not in its specific details, but in its central premise, that advanced civilizations existed and disappeared due to catastrophic changes in sea levels. The 9,000 years before Plato mentioned correspond approximately to the period of the most dramatic meltwater pulses. Even the detail about the disappearance in a single day and night might not be a poetic exaggeration. Computational models of ice sheet collapses suggest that certain types of glacial destabilization could cause sea level rises of several meters in extremely short periods, possibly days or weeks, instead of decades. Our planet's oceans continue to guard secrets that could completely transform our understanding of human history. Every new marine archaeology expedition, every advance in underwater exploration technologies, reveals additional evidence that the history of human civilization is much older and more complex than we have imagined. In the silent depths of the oceans, where sunlight never penetrates and where time seems to have stopped, lie the remnants of worlds that once bustled with human activity, cities where generations lived, worked, and dreamed of the future, temples where people worshipped gods whose names have been lost forever, libraries where knowledge accumulated over millennia was preserved in forms we can no longer read. These submerged worlds remind us that the geography of our planet is not static, that the continents and oceans we consider permanent have changed dramatically throughout human history, and that they will continue to change. They teach us that civilizations, no matter how advanced or powerful, are at the mercy of geological and climatic forces that operate on timescales that exceed human planning. And perhaps, most importantly, they suggest that the history we think we know might be only the most recent chapter in a much longer and more complex narrative of civilizational ascent, flourishing, and transformation that extends much further back in time than we have ever dared to imagine. If you could travel into the Earth, crossing the layers of rock and sediment that have accumulated over billions of years, you would find something extraordinary. A history book written in stone that documents every catastrophe, every rebirth, and every reboot that our planet has experienced since the dawn of life. Every geological stratum is a page in this planetary library, and when scientists learn to read this record, they discover a story that is simultaneously familiar and terrifying. The sedimentary rocks that form much of the terrestrial surface were deposited layer by layer over millions of years, like the pages of an infinite diary. Each layer captures a specific moment in Earth's history, the types of life that existed, the climatic conditions that prevailed, and the dramatic events that altered the course of evolution. And when geologists examine these layers carefully, they find evidence of something that should make us reflect deeply. Our planet has experienced at least 5 documented mass extinctions, events so devastating that they eliminated between 70 and 96% of all living species. These were not gradual events that unfolded over millions of years. They were rapid and dramatic planetary reboots that fundamentally altered the composition of life on Earth in geologically instantaneous periods. Each one marks a clear boundary in the fossil record, a moment when life forms that had dominated the oceans and continents for eons suddenly disappeared, leaving space for new species to evolve and flourish. The first great mass extinction occurred 445 million years ago at the end of the Ordovician period. The oceans of that time were filled with creatures that would seem alien to us today. Trilobites, with complex compound eyes, brachiopods that filtered plankton from the seawater, and giant cephalopods that dominated the marine food chains. But when geologists examine the rock layers from this period, they find evidence of a sudden collapse of these ecosystems. Sediments reveal that sea levels dropped dramatically, ocean temperatures fluctuated violently, and the chemistry of the seawater changed in ways that made survival impossible for many life forms. Approximately 85% of marine species became extinct. But what is fascinating is how life responded to this reboot. New types of organisms evolved to fill the empty ecological niches, developing innovative adaptations that had never existed before. The second mass extinction, 375 million years ago, during the late Devonian period, eliminated many of the fish species and terrestrial plants that had begun to colonize the continents. But again, the geological record shows that this apparent disaster functioned as a catalyst for new forms of evolution. The survivors diversified rapidly, developing adaptations that allowed for more successful terrestrial colonization. The third mass extinction was the most devastating of all. 252 million years ago, at the end of the Permian period, an event known as the Great Dying eliminated approximately 96% of marine species and 70% of terrestrial species. It was the most complete reboot our planet has experienced, so severe that it took 10 million years for biodiversity to fully recover. Geologists have found evidence that this extinction was caused by massive volcanic eruptions in what is today Siberia. These eruptions, known as the Siberian traps, released immense quantities of toxic gases and dramatically altered the composition of the atmosphere for thousands of years. But what emerges from the fossil record after this catastrophe is remarkable. Completely new life forms that had never existed before, including the first dinosaurs and the ancestors of modern mammals. The fourth mass extinction, 201 million years ago, at the end of the Triassic, set the stage for the dominance of the dinosaurs for the next 135 million years. And the fifth, the event that eliminated the dinosaurs 66 million years ago, created the opportunities that allowed the evolutionary radiation of mammals and eventually the emergence of primates and humans. But the geological record reveals something more intriguing than these 5 major events. When paleontologists examine extinction data with greater temporal resolution, they discover evidence of dozens of minor extinctions that follow similar patterns, events that eliminated between 30 and 60% of existing species, followed by periods of accelerated evolutionary innovation and diversification. These mini-reboots seem to follow regular cycles that correspond with various astronomical and geological phenomena. Some coincide with periods of increased volcanic activity, others with changes in the Earth's orbital patterns, and others with evidence of asteroid impacts smaller than the mass extinction events. What is particularly fascinating is how these patterns of extinction and renewal have accelerated during the last 65 million years, the period known as the Cenozoic era. It is as if our planet has entered a phase of faster evolutionary experimentation, with more frequent reboots and more accelerated diversification. During the Cenozoic era, the geological record documents at least 12 significant extinction events, each followed by evolutionary radiations that produced new life forms adapted to changing environmental conditions. The evolution of mammals, birds, flowering plants, and eventually primates occurred during these periods of post-extinction renewal. Scientists have begun to recognize that these reboots are not unfortunate interruptions in the evolutionary process, but an integral part of how life develops and adapts on our planet. Each extinction eliminates life forms that had become too specialized or dependent on specific conditions, creating opportunities for more flexible and innovative adaptations to emerge. This pattern has profound implications for our understanding of humanity's place in Earth's history. We are products of multiple planetary reboots, descendants of species that survived when many others perished. Our evolutionary lineage is marked by critical moments when small populations of our ancestors managed to persevere through conditions that eliminated most of their contemporaries. But the geological record also suggests something unsettling, that we might be living during the beginning of another mass extinction event. Paleontologists have documented that current rates of species extinction are between 100 and 1,000 times higher than normal background rates. The chemical composition of the atmosphere is changing more rapidly than it has for millions of years. Global climate patterns are altering in ways that recall previous periods of mass extinction. Some scientists have proposed that we have entered the 6th mass extinction, an event that could rival the catastrophes of the geological past. But unlike previous extinctions, which were caused by volcanoes, asteroids, or natural climate changes, this 6th extinction appears to be primarily driven by human activities. The critical difference is that for the first time in our planet's history, a species is aware that it might be causing its own planetary reboot. We have the capacity to study the geological record, to understand the patterns of extinction and renewal in the past, and potentially to intervene, to alter the course of events. The rock layers that document previous extinctions contain important lessons about how life responds to planetary crises. They show that survival favors species that are adaptable, cooperative, and capable of innovating rapidly in response to changing conditions. They also reveal that the most diverse and complex ecosystems tend to be more resilient during periods of environmental stress. But perhaps the most important lesson from the geological record is that planetary reboots, although devastating in the short term, have been fundamental in driving evolution toward more complex and sophisticated life forms. Without the mass extinctions of the past, Mammals would never have had the opportunity to diversify, primates would never have evolved, and human intelligence would never have emerged. This raises a profound question. If we are truly at the beginning of a sixth mass extinction event, what life forms might emerge from this reboot? Could humanity itself evolve into something fundamentally different? Or could we be replaced by completely new life forms that are better adapted to the planetary conditions we are creating? The geological record suggests that such transformations are not only possible, but inevitable over sufficiently long timescales. Fossils teach us that no life form, no matter how successful or dominant, persists indefinitely without change. Life on Earth is characterized by periods of relative stability, interrupted by rapid and dramatic transformations. In the most recent layers of the geological record, scientists have begun to find evidence of the human era. Elevated concentrations of carbon dioxide trapped in ice cores, deposits of plastics and metals that never naturally existed, and changes in sedimentation patterns that reflect human alterations of the landscape. These geological markers of the human presence, known as the Anthropocene, could eventually form a distinctive layer in the rock record that future intelligent species might study to understand our civilization. Just as we study the layers that document civilizations of trilobites, dinosaurs, and other life forms of the past, the question is, what story will that layer tell about us? Will it document a species that learned to live in harmony with the planetary systems that sustained it? Or will it record another mass extinction, another reboot in the long chain of transformations that have characterized the history of life on our planet? In the deep silence of this night, as you rest surrounded by rocks that have been silent witnesses to billions of years of planetary change, consider that every stone under your feet carries the memory of worlds that have existed and disappeared. In their crystals and sediments are preserved the evidence of catastrophes that eliminated dominant life forms and of renewals that created opportunities for new species to thrive. These rocks remind us that we are part of a much larger story than our individual experience or even the history of our species. We are participants in a planetary process of extinction and renewal that has been operating for more than 3,500 million years, and that will continue long after our current civilization has become part of the fossil record. 150 million kilometers away, our parent star continues its cosmic dance of nuclear fusion, converting 4 million tons of hydrogen into helium every second, and releasing an amount of energy that is impossible to fully comprehend. This energy travels through the vacuum of space for 8 minutes and 19 seconds before reaching the Earth, where it drives every process that sustains life. The photosynthesis that converts light into food, the evaporation that creates clouds and rain, the winds that redistribute heat around the planet. But the Sun is not a perfectly stable star. Its energy output varies in complex cycles that operate on multiple temporal scales, from daily fluctuations to changes that extend over millennia. For most of human history, these variations seemed subtle and irrelevant to daily life. But scientists have begun to discover that long-term solar cycles have functioned as one of the most powerful and systematic reboot mechanisms our planet has experienced. The most dramatic evidence of this phenomenon comes from the study of the Little Ice Age, a period of global cooling that extended from approximately the year 1400 to 1850. During these 4.5 centuries, global temperatures dropped between 1 and 2 degrees Celsius, a seemingly small decrease that had devastating consequences for human civilizations of the time. Rivers that had never frozen in recorded memory became solid for months. Alpine glaciers advanced, destroying entire villages that had existed for centuries. Harvests failed repeatedly, causing famines that killed millions of people. In some regions, the growing season shortened so much that agriculture became impossible, forcing the abandonment of settlements that had been prosperous for generations. But what is most intriguing about the Little Ice Age is that it coincided precisely with a period of extremely low solar activity. Historical records of solar observations, combined with analysis of carbon isotopes in tree rings and ice cores, reveal that during this period, the Sun experienced several prolonged minimums of activity. The Spura minimum, which lasted from 1460 to 1550, and the Maunder minimum, from 1645 to 1715, were periods when sunspots practically disappeared for decades. Sunspots are regions on the solar surface where intense magnetic fields inhibit convection, creating areas that appear darker because they are approximately 2000 degrees Celsius cooler than the rest of the solar surface. The number and intensity of sunspots follow a cycle of approximately 11 years, but this cycle can be interrupted or suppressed for prolonged periods when the Sun's magnetic activity dramatically decreases. During prolonged solar minimums like the Maunder minimum, the Sun's total energy output is reduced by only a fraction of a percent, an amount that would seem insignificant. But the effects on the terrestrial climate are amplified by complex feedbacks in the atmosphere and oceans. When less solar energy arrives, fewer clouds form, allowing more heat to radiate into space. Ocean currents weaken, reducing the transport of heat from the tropics toward the poles. Precipitation patterns are altered, affecting agriculture and ecosystems worldwide. Paleoclimatologists have identified multiple similar periods throughout recorded history. The Oort minimum, which lasted from 1040 to 1180, coincided with a period of cooling that affected medieval agriculture and contributed to the collapse of the Viking colonization in Greenland. The Wolf minimum, from 1280 to 1345, is associated with the end of the medieval warm period and the beginning of more difficult climatic conditions that persisted for centuries. But these historical solar minimums might be merely faint echoes of much more dramatic events that have occurred over longer timescales. Cosmogenic studies, which analyze isotopes produced by cosmic rays in the terrestrial atmosphere, suggest that the Sun has experienced much more severe and prolonged minimums of activity during the last 10,000 years. These grand solar minimums could last not decades, but centuries, or even millennia. During such periods, the reduction in solar irradiance could be sufficient to trigger partial or complete ice ages, fundamentally altering climatic conditions across the entire planet. Civilizations that had flourished during periods of normal solar activity would suddenly find themselves facing conditions that would make it impossible to maintain their populations, agricultural systems, and complex social structures. Ice core records from Greenland and Antarctica contain evidence of at least 12 grand solar minimums during the last 11,000 years. Each one is associated with periods of global cooling, reduced precipitation, and alterations in atmospheric circulation patterns. Some coincide with known civilizational collapses: the end of the Western Roman Empire, the fall of the classic Maya civilization, and the collapse of multiple societies during the Late Bronze Age. It is possible that these collapses, which historians have traditionally attributed to political, economic, or military factors, were actually caused or precipitated by climate changes induced by solar variations. Evidence suggests that reduced solar activity could have been the trigger that made civilizations already stressed by other problems become unsustainable. Analysis of ancient tree growth rings reveals patterns of reduced growth that correspond with the grand solar minimums. During these periods, summers became cooler and shorter, growing seasons shortened, and precipitation decreased in many regions. For agricultural societies, that depended on predictable harvests, these changes would have been catastrophic. More complex civilizations with large urban populations that depended on agricultural surpluses would have been particularly vulnerable. When harvests failed repeatedly for decades, efficient food storage and distribution systems would have collapsed. Urban populations would have been forced to disperse to rural areas, fragmenting the commercial and cultural networks that sustained complex societies. But grand solar minimums do not only affect the climate through changes in irradiance, they also dramatically alter the magnetic field surrounding the solar system, known as the heliosphere. During periods of low solar activity, this magnetic shield weakens, allowing more galactic cosmic rays to penetrate the inner solar system and reach the Earth. Cosmic rays are high-energy particles, mainly protons, that travel through interstellar space at near the speed of light. When these particles impact the terrestrial atmosphere, they create cascades of secondary particles that can affect cloud formation, atmospheric chemistry, and possibly even biological processes. Some scientists have proposed that during grand solar minimums, the increase in the cosmic ray flux could catalyze the formation of low clouds, increasing the Earth's reflectivity and amplifying the cooling caused by reduced solar irradiance. Others have suggested that cosmic rays could directly affect living organisms, increasing mutation rates and potentially influencing the course of evolution. Paleoclimate records suggest that some of the most dramatic environmental changes of the last 100,000 years could have been triggered by extreme solar variations. The Younger Dryas event, which we discussed in previous chapters, occurred during a period of particularly low solar activity. The multiple climatic collapses during the Middle Holocene that affected civilizations from Mesopotamia to the Indus Valley correspond with evidence of prolonged solar minimums. Could variable solar activity have been the systematic reboot mechanism that has shaped the history of human civilization? The temporal patterns suggest it is a serious possibility. Grand solar minimums seem to occur with an approximate periodicity of 1,000 to 2,000 years, coinciding with many of the cycles of civilizational ascent and collapse that we observe in the historical record. This perspective would fundamentally alter our understanding of why civilizations rise and fall. Instead of seeing these cycles as the result of purely human factors, political decisions, military conflicts, or resource depletion, we would have to recognize that they might be driven by cosmic forces operating completely outside of human control. Modern climate models suggest that even relatively small solar variations can have disproportionately large effects on terrestrial climate systems due to complex feedbacks in the atmosphere, oceans, and cryosphere. A 1% reduction in solar irradiance, sustained for decades, could be sufficient to fundamentally alter global precipitation patterns and reduce temperatures enough to make agriculture impossible in many regions that are currently productive. What is particularly unsettling is that astrophysicists have identified evidence that the Sun might be approaching another grand minimum. Observations of solar activity during the last decades show trends that recall the periods preceding historical minimums. Solar cycle 24, which reached its maximum in 2014, was notably weaker than previous cycles. Solar cycle 25, which began in 2020, also shows signs of reduced activity. Some solar activity models suggest that we might be entering a period of reduced solar activity that could last decades or even centuries. If this occurs, we could experience significant global cooling, alterations in precipitation patterns, and disruptions in the agricultural systems that sustain billions of people. But unlike past civilizations, we have capabilities that could allow us to adapt to such changes. Our understanding of climate systems is much more sophisticated. Our agricultural technologies are more flexible, and our communication and transportation systems could allow for resource redistributions that would have been impossible for earlier societies. At the same time, our globalized civilization might also be more vulnerable to systematic disruptions. We rely on complex and interconnected supply systems that could collapse in cascade if climate patterns were dramatically altered. Our massive urban populations require constant imports of food from regions that could be severely affected by climate changes induced by solar variations. The critical question is whether we could recognize and prepare for a grand solar minimum before its effects become devastating. Solar scientists have developed models that could provide us with decades of advance warning if the sun began to enter a state of prolonged reduced activity. But translating those predictions into practical preparation would require levels of international cooperation and long-term planning that have been historically difficult to achieve. In the silence of this night, as the world rests under the faint glow of the stars, our star continues its incessant process of nuclear fusion. In its core, at temperatures of 15 million degrees Celsius, atoms fuse in reactions that determine not only the brightness of our star, but potentially the destiny of our civilization. Magnetic fields twist and reorganize in patterns that could, in the coming decades, decide whether we enter a new era of climatic prosperity or face another of the solar reboots that have shaped human history for millennia. In every ray of light that reaches us from the sun is encoded information about the state of our star, clues about its future behavior that scientists are only beginning to decipher. And in that information could be the key to understanding not only our past, but also our future as a planetary civilization. In museums around the world, behind carefully illuminated glass display cases, lie artifacts that silently challenge our established chronologies, objects that seem too sophisticated for the dates archaeologists have assigned them, technologies that supposedly should not have existed during the periods from which they originate, and evidence of knowledge that our history books insist was not developed until thousands of years later. For decades, these anomalous artifacts have been catalogued, dated, and archived, but they have rarely been integrated into a coherent narrative about human development. Scholars treat them as curiosities, interesting exceptions that do not alter our fundamental understanding of how civilizations evolved over time. But when we begin to examine these objects as a whole, when we consider the possibility that they are not anomalies, but fragmentary survivors of lost traditions, a pattern emerges that suggests something extraordinary, that multiple advanced civilizations have existed and completely disappeared from the historical record. The National Museum of Costa Rica exhibits a collection of small gold figures that archaeologists have dubbed pre-Columbian flying objects. These figures, dating from between 500 and 800 years of our era, show characteristics that are difficult to interpret as representations of known animals. They have aerodynamic fuselages, structures that resemble airplane wings, and details that suggest a knowledge of aerodynamic principles that supposedly were not developed until the 20th century. When aeronautical engineers have analyzed these objects, they have found that their proportions correspond remarkably well with modern aircraft designs. Some have built functional models based on these golden figures and demonstrated that they can indeed fly, suggesting that whoever created them had at least some practical understanding of aerodynamics. In Iraq, archaeological excavations have revealed what appear to be primitive electric batteries dating back more than 2,000 years. These objects, known as the Baghdad batteries, consist of ceramic jars containing copper cylinders and iron rods. When filled with an acidic electrolyte, they generate approximately 1 volt of electricity. Experiments have shown that they could have been used to electroplate metal objects, a technique that was supposedly not developed until the 19th century. In Egypt, temple reliefs at Dendera show images that some researchers have interpreted as primitive electric light bulbs. The figures show elongated, bulbous objects connected to what appear to be cables, supported by characters that might represent insulators. Although conventional Egyptologists interpret these images as symbolic representations of religious myths, the similarities to modern electrical equipment are specific enough to generate continuous debate. In India, ancient Sanskrit texts contain detailed descriptions of flying vehicles called vimanas. The Vaimanika Shastra, although of controversial date, provides technical specifications, including different types of metals, fuels, and propulsion mechanisms. Some of these texts describe principles that resemble concepts of modern aerodynamics, including references to different types of metal alloys and construction techniques that should not have been known in antiquity. In Peru, the Nazca lines continue to defy satisfactory explanations. These enormous geometric figures and animal representations, some of which extend for kilometers, are only fully visible from the air. Their construction would have required not only sophisticated engineering capabilities, but also some method for designing and verifying patterns that can only be appreciated from considerable altitudes. Recent studies have revealed that the Nazca lines are even more complex than previously thought. Using remote sensing technologies, archaeologists have identified more than 1,000 additional lines that form intricate geometric patterns, suggesting an advanced knowledge of mathematics and astronomy. Some of these lines appear to point towards specific positions of celestial bodies during particular historical periods, suggesting they might have functioned as a kind of massive astronomical calendar. In Colombia, Muisca culture gold artifacts include figures that show anatomical and technological characteristics that do not correspond to any known animal in the region. Some show what appear to be helmets or breathing apparatus. Others have appendages that resemble mechanical wings or thrusters. The details are specific enough to suggest that the artists were working from direct observations rather than pure imagination. In China, ancient texts describe technologies, including mirrors that could show events occurring in distant places, lamps that burned for years without fuel, and mechanical devices capable of performing complex calculations. Although many of these accounts have been dismissed as fantastic legends, some contain technical details specific enough to suggest they might be based on real technologies that were subsequently lost. The unsettling question is, if these artifacts and descriptions represent evidence of advanced technologies that existed in the past, what happened to the civilizations that created them? Why were these capabilities seemingly lost and had to be rediscovered thousands of years later? One possibility is that these objects represent fragmentary survivors of civilizations that were eliminated by the reboot events we have discussed in previous chapters. Dramatic climate changes, asteroid impacts, massive volcanic eruptions, or solar collapses could have destroyed the social and technical infrastructures necessary to maintain sophisticated technologies. When a civilization completely collapses, technical knowledge can disappear remarkably quickly. Complex technologies require specialized supply chains, technical workshops, and educational traditions that take generations to develop but can fragment in decades. Survivors of a civilizational collapse would concentrate on immediate survival needs, and specialized techniques not directly relevant to basic survival would be quickly lost. This pattern can be observed even in documented historical collapses. When the Roman Empire fragmented, engineering, medicine, and manufacturing techniques were lost that were not recovered for centuries. The manufacture of Roman concrete, which was superior to modern concrete in many aspects, was completely lost and has only been partially reconstructed in recent times, and much older civilizations experienced even more severe collapses. It is conceivable that much more advanced technologies could have been completely lost, leaving only confusing fragments that later archaeologists could not correctly interpret. Metallurgical analyses of some ancient artifacts have revealed alloys and processing techniques that are surprisingly sophisticated. The Iron Pillar of Delhi in India, dating back at least 1,600 years, is made of an iron that is practically free of impurities and resistant to corrosion in ways that modern metallurgy struggles to replicate. The techniques used to produce this material were apparently completely lost. In South America, analyses of some pre-Columbian gold objects have revealed alloys that require very advanced refining techniques. Some contain precise proportions of metals that would be difficult to achieve without sophisticated knowledge of metallurgical chemistry. Others show evidence of soldering and molding techniques that were supposedly not developed until much later historical periods. The megaliths scattered around the world present similar enigmas. Sites like Pumapunku in Bolivia show evidence of stone-cutting techniques that produce surfaces so smooth and angles so precise that they are difficult to replicate even with modern tools. The stone blocks are cut with tolerances that suggest the use of precision tools and advanced knowledge of geometry. In Baalbek, Lebanon, the stone blocks used in construction include some that weigh more than 800 tons. Moving and positioning such blocks would have required engineering technologies that officially did not exist when they were supposedly placed. The methods that modern engineers would use for such tasks would involve equipment that leaves characteristic marks on the stone, but these marks are absent at Baalbek. The astronomical precision of many megalithic sites suggests traditions of observation that extended over millennia. To construct structures that precisely align with celestial events that occur in cycles of thousands of years, the builders would have needed to maintain accurate astronomical records for periods that exceed the duration of many known historical civilizations. This continuity of astronomical knowledge across such long timescales suggests civilizations with stable institutions and sophisticated educational traditions that were able to preserve and transmit complex technical information for dozens of generations. However, we do not find clear evidence of such institutions in the archaeological record of the relevant periods. One unsettling possibility is that the evidence of these institutions was systematically destroyed by reboot events, leaving only the most massive and durable monuments as silent witnesses to lost traditions. The buildings, libraries, workshops, and educational centers that would have sustained these traditions might have been built with materials that did not survive the catastrophes that eliminated the civilizations that created them. Ancient texts from many cultures contain references to earlier periods of greater knowledge and technical capability. The Sumerians wrote about the Anunnaki, beings who supposedly brought civilization and technical knowledge to humanity. The Egyptians referred to Zep Tepi, a first time when the gods walked among humans and established the foundations of civilization. The Hindus described earlier Yuga, when humanity possessed knowledge and capabilities that were subsequently lost. For a long time, scholars have interpreted these traditions as religious mythology, but it is possible that they preserve distorted cultural memories of earlier civilizations that truly existed and possessed advanced technologies that were subsequently lost during reboot events. The global distribution of these traditions of lost golden ages is notable. Cultures that supposedly had no contact with each other developed surprisingly similar narratives about earlier periods of greater knowledge and capability. This suggests they might be based on real historical experiences rather than independent inventions. DNA studies of current human populations have revealed evidence of multiple genetic bottlenecks during the last 100,000 years, periods when human populations dramatically reduced before expanding again. Each of these bottlenecks could represent a reboot event that eliminated existing civilizations and forced the survivors to rebuild from fragments. If this pattern of collapse and reconstruction has occurred multiple times during human prehistory, it would explain why we find tantalizing evidence of advanced technologies in unexpected archaeological contexts. These artifacts might be exactly what we would expect to find: the surviving remnants of technical traditions that were developed by earlier civilizations, lost during reboot events, and partially recovered by later civilizations. In the silence of this night, as you contemplate the stars that have been silent witnesses to all of human history, consider that in the world's museums and archaeological collections might exist the pieces of a much larger puzzle that we are only beginning to solve. Every anomalous artifact, every textual description of impossible technologies, every megalith that defies explanation could be a window into lost worlds that flourished and disappeared long before we began to record our history. These fragments whisper stories of human achievements that extend much further back in time than we have imagined, of civilizations that perhaps reached heights that we have not yet equaled, but which were erased so completely by forces that were beyond their control that we can now barely discern their existence in the vestiges they left behind. As this night draws to a close, and the first lights of dawn begin to appear on the horizon, it is time to confront the question that has been whispered silently through every chapter of this journey. If planetary reboots have shaped the history of our world for millions of years, if civilizations have risen and fallen in regular cycles, if our own planet operates according to patterns of renewal and transformation that transcend the human scale, then where do we stand in this cosmic sequence? Scientists studying these patterns have begun to identify unsettling signs that we might be approaching another tipping point in planetary history. They are not dramatic signals that capture news headlines, but subtle and systematic changes in the fundamental systems that sustain life on Earth. Changes that, when considered together, create a pattern that is simultaneously familiar and terrifying. The first signal is written in the ice. Cores extracted from Greenland and Antarctica show that atmospheric concentrations of carbon dioxide have reached levels not seen for more than 3 million years. But what is more concerning is not the absolute levels, but the speed of the change. Changes that normally take millennia are occurring in decades, an acceleration that recalls the periods of rapid transition that have preceded previous reboots. The second signal comes from the behavior of our planetary magnetic field. The magnetic North Pole is moving faster than ever in recorded history, shifting from the Canadian Arctic towards Siberia at a speed of approximately 50 kilometers per year. At the same time, the overall intensity of the Earth's magnetic field has significantly decreased during the last 150 years. These changes suggest that we might be approaching a magnetic pole reversal, an event that has occurred hundreds of times in geological history and has, each time, had profound consequences for life on the surface. During a magnetic reversal, the protective shield that guards us from cosmic radiation weakens dramatically for centuries or millennia. Satellite communication systems, electrical grids, and other aspects of modern infrastructure would be vulnerable to radiation storms that could cause systematic collapses, but the effects could be much deeper. Paleontological studies suggest that magnetic reversals frequently coincide with mass extinctions and accelerated evolutionary changes. The third signal comes from space. Astronomers have documented that our solar system is moving toward a region of the galaxy with a higher density of cosmic dust and radiation. At the same time, recent observations suggest that the Sun might be entering a prolonged period of reduced activity, similar to the grand minimums that have triggered minor ice ages in the past. The combination of these factors, a weakened magnetic shield, greater exposure to cosmic radiation, and reduced solar activity, could create conditions similar to those that have preceded some of the most dramatic reboots in planetary history. The fourth signal is written in the oceans. The thermohaline currents that redistribute heat around the planet are showing signs of destabilization. The Gulf Stream has weakened significantly over the last decades. The Atlantic meridional overturning circulation, which has operated relatively stably for millennia, shows fluctuations that suggest it might be approaching a tipping point of collapse. If these ocean currents were to stop, as occurred during the Younger Dryas, the climatic consequences would be catastrophic. Europe could experience cooling of 10 degrees Celsius or more. Precipitation patterns in the tropics would be dramatically altered. Climate systems that have sustained agriculture and civilizations for thousands of years could be transformed in a matter of decades. The fifth signal comes from the biosphere itself. Species extinction rates have reached levels previously seen only during the 5 mass extinctions of geological history. Ecosystems that have existed for millennia are fragmenting and collapsing. Coral reefs, tropical forests, wetlands, and other critical habitats are disappearing at speeds that suggest we might be in the early stages of the 6th mass extinction. But unlike previous extinctions, which were caused by volcanoes, asteroids, or natural climate changes, this one appears to be driven by human activities. For the first time in the planet's history, a single species has become powerful enough to alter the fundamental systems that sustain life. This creates an extraordinary paradox. We might be causing our own planetary reboot. The same intelligence and technological capacity that allows us to study and understand the reboot patterns of the past has also given us the power to trigger similar processes. The most sophisticated climate models suggest that we are approaching multiple tipping points in terrestrial systems. The collapse of the Greenland and West Antarctic ice sheets could raise sea levels several meters over the next centuries. The melting of Arctic permafrost could release massive amounts of methane and carbon dioxide, accelerating climate change beyond the capacity of many ecosystems to adapt. Ocean acidification could collapse marine food chains. Each of these processes, once initiated, could become self-sustaining and irreversible on human timescales. Together, they could create exactly the kind of rapid and dramatic planetary transformation that has characterized the reboots of the past. But does this mean we are condemned to experience another civilizational collapse? Or does our understanding of these patterns give us capabilities that earlier civilizations did not have to avoid or mitigate a reboot? For the first time in the planet's history, a species is aware of the reboot patterns that have shaped the history of life. We have the capacity to study the geological record, to understand the mechanisms that have caused previous mass extinctions, and to monitor planetary systems in real time. We have technologies that could, in principle, allow us to intervene in some of these processes. We could develop techniques to remove carbon dioxide from the atmosphere. We could create refuges for threatened species. We could decentralize our food production systems to make them more resilient to climatic disruptions. We could preserve technical and cultural knowledge in forms that could survive civilizational collapses. But doing these things would require levels of international cooperation, long-term planning, and short-term sacrifice that have been historically difficult to achieve. Previous civilizations that experienced reboots were not less intelligent or capable than we are. They simply faced forces that exceeded their capacity to respond. Studies of historical civilizational collapses reveal common patterns. Societies tend to respond to crises by maintaining the strategies that made them successful in the past, even when those strategies become counterproductive under changing conditions. Elites continue to extract resources even when the system that sustains them is disintegrating. Populations refuse to believe that their way of life might not be permanently sustainable. We are exhibiting similar patterns. Our global civilization continues to operate under the assumption that infinite economic growth is possible on a finite planet. We continue to extract resources and produce waste at rates that exceed the capacity of natural systems to regenerate. We continue to fragment the ecosystems that sustain life and alter the climate systems that have allowed the flourishing of human civilization. At the same time, we have capabilities that no previous civilization possessed. We can communicate instantly across continents. We can share knowledge and coordinate actions on global scales. We can simulate complex systems and predict the consequences of our actions with unprecedented accuracy. The critical question is whether these capabilities will be enough to break the pattern of reboots that has characterized planetary history, or if they merely allow us to document our own collapse in greater detail than any previous civilization. The next centuries will likely determine the answer. If we manage to stabilize the climate, preserve biodiversity, and develop sustainable forms of planetary life, we could become the first civilization in Earth's history to successfully avoid a reboot. If we fail, we could become another chapter in the geological record, a layer of sediment that future intelligent species might study to understand how a technologically advanced civilization self-destructed. But even if we face a reboot, history teaches us that these events, though devastating, are not final. Life persists, intelligence emerges, civilizations rebuild. The reboots we have examined were not terminations, but transformations. Each one created opportunities for new life forms, new types of intelligence, and new experiments in social organization and technological development. If we are part of a larger cycle of ascent, flourishing, and renewal that operates on cosmic scales, then our role might not be to avoid the reboot, but to influence its nature and prepare the way for what comes next. We could be the temporary custodians of knowledge and achievements that need to be preserved and transmitted through the next period of transformation. On Data Terra, we have explored this possibility not to generate despair, but to foster perspective. Understanding the patterns of the past helps us navigate the present with greater wisdom. Recognizing our position on cosmic timescales helps us value both the fragility and the resilience of life and civilization. As you rest tonight, consider that every breath you take connects your body to the atmosphere that has sustained life for billions of years. Every beat of your heart participates in biological processes that have persisted through multiple mass extinctions and planetary reboots. Every thought you have is part of a tradition of intelligence that might extend much further back in time than we have imagined. No matter what the future brings, no matter whether we face another planetary reboot or manage to transcend these ancient patterns, we are part of something much larger and more enduring than our individual lives, or even our current civilization. We are participants in the most extraordinary experiment in the known universe, the emergence of consciousness from inert matter, the capacity of matter to contemplate itself and to question its origin and destiny. The reboots of the past remind us that nothing remains unchanged forever, but they also teach us that the capacity for adaptation, innovation, and renewal is a fundamental characteristic of life. Whatever future awaits us, we carry within us the genes, the memories, and the capabilities of all the survivors who preceded us. We are the heirs of millions of years of successful persistence through transformations that seemed impossible to survive. In that inheritance lies both our responsibility and our hope. And in the silence of these final hours before dawn, as the world prepares for another day in this extraordinary experience of conscious existence, we can find peace in knowing that, no matter what tomorrow brings, we are part of a story that is much older, more complex, and more resilient than we have ever imagined.